In the Solve It, you formed a polygon on a grid. In this lesson, you'll classify polygons in the coordinate plane. The chart on the next slide reviews these formulas and when to use them. First, recall the distance formula. D, the distance, equals the square root, big square root sign, of the quantity x2 minus x1 squared plus y2 minus y1 squared. And when to use it? We're going to use it to determine whether sides are congruent or diagonals are congruent as we consider polygons on the coordinate plane. Next, the midpoint formula. Remember this one, capital M, standing for the midpoint, equals two coordinates, an x-coordinate and a y-coordinate. But the way that we compute these is to take two x-coordinates that are known, x1 and x2, add them together and divide by 2. That gives us the x-coordinate of the midpoint. To find the y-coordinate, we take y1 plus y2 divided by 2. Keep in mind, these aren't just any x and y values, they're the endpoints. So x1, y1 will be one endpoint, x2, y2 will be the other endpoint. I'm not sure if I was clear on that earlier. We're going to use this to determine the coordinates of the midpoint of a side, and to determine whether diagonals bisect each other. Finally, the slope formula. Slope, lowercase m, equals y2 minus y1, which we often refer to as rise, over x2 minus x1, which we often refer to as run. We're going to use the slope formula to determine whether opposite sides are parallel, whether diagonals are perpendicular, and whether sides are perpendicular. Problem 1. Classifying a triangle. Is triangle ABC scalene, isosceles, or equilateral? Well, the vertices of the triangle are A at point 0, 1, B at point 4, 4, and C at point 7, 0. Those numbers become important. We're going to find the lengths of the sides using the distance formula. Because remember, scalene, isosceles, and equilateral are all classifications of a triangle based on its side lengths. So we need to know the side lengths. AB will equal 4 minus 0 squared plus 4 minus 1 squared, and then we take the square root of that. Substituting, simplifying, we find that AB equals 5. We follow a similar process to find the length BC, that's 5, and then CA turns out to equal the square root of 50, which simplifies to 5 times the square root of 2. So this side's not congruent with the other two, but the other two are congruent with one another, meaning it's an isosceles triangle. To justify that, we can make the statement, since AB equals BC equals 5, then triangle ABC is isosceles. Your turn. Triangle DEF has vertices D, 0, 0, the origin, E at 1, 4, and F at 5, 2. Is triangle DEF scalene, isosceles, or equilateral?